Hello everyone and welcome back to my channel. I'm Emily Gaddam, a nurse, infection preventionist, and a specialist in health delivery science. In today's video, we're diving deeper into the fascinating world of statistical process control, or SPC charts. We'll continue to use cookie size as our example, but keep in mind you can apply these concepts to any continuous variable of your choice. Before we get started, I want to address some feedback I received. Many of you mentioned that you would like more information on calculating the upper and the lower control limit. I apologize for the last video having microscopic Excel spreadsheet. So to address your request, I'll be redoing the second video or creating a new one that specifically focuses on calculating control limits, making it easier to follow step by step. Once you're able to calculate the control limits, there's no really hard math from there on out. When we talk about the rules of SPC charts, when I was studying for my CIC exam, I have to admit I thought they seemed a bit ridiculous. But as I've delved deeper into statistics, I've come to appreciate their use and simplicity. Even a kindergartner could learn to follow these rules, and you don't need any advanced statistical knowledge apart from setting the central line and the control limits in the first place. All right, so let's jump into the first rule of analyzing SPC chart using our cookie size. But remember again, you can use these rules with any continuous variable that you're interested in monitoring. Okay, let's take a closer look at the first rule of analyzing an SPC chart. One point outside the upper or lower control limits. This rule is all about keeping an eye out for those standout cookie sizes that venture beyond the control limits specified on the SPC chart. You see, control limits are like boundaries that we set on the SPC chart to help us determine if our process is in control or not. They're typically set at 3 standard deviations from the process mean. So when we spot a cookie size that falls outside these limits, it's a signal that something noteworthy might be happening. It's important to remember that control limits provide a reference range based on the variability of our process. So when we encounter a single cookie size that goes beyond these boundaries, it could indicate a special cause variation, a factor outside the usual process that needs our attention. Now that we've explored the first rule, let's move on to the next one and continue our quest for SPC wisdom. But before we do, take a moment to appreciate the cookie size example we're using. Who knew cookies could teach us so much about process control? Now for rule number 2. 2 out of 3 successive data points more than 2 standard deviations from the mean on the same side of the center line. To visualize this rule, take a look at the line graph on my screen. The green area represents data points within 2 standard deviations from the mean, while the orange and the red areas indicate points beyond 2 and 3 standard deviations respectively. Now imagine if we have a series of cookie size measurements. Suppose we observe a single data point that falls below our central line, or above our central line in this case. It raises our attention, but it doesn't necessarily indicate a significant deviation just yet. However, if we notice 2 out of the next 3 consecutive cookie sizes falling beyond 2 standard deviations from above the mean, all on the same side of the center line, it suggests a potential trend or shift in the process. This pattern is a red flag that the process may be undergoing a significant change. It could be due to factors such as a shift in ingredients, changes in baking conditions, or other variations that need investigation. Speaking of deviations, imagine we end up with a cookie that's way too big. It might look impressive, but if you're a business, it could mean you're using too many resources for what the customer is paying. That's one cookie you definitely can't debate. It's inefficiency. I know, that was super cheesy. All right, let's keep the cookie sized universe in check as we move on to the next rule. All right, rule number 3. Imagine we're monitoring the cookie sizes again and we spot a single data point that falls beyond one standard deviation from the mean. It catches our attention, but it might not be a cause for major concern just yet. However, if we observe that 4 out of the next 5 consecutive cookie sizes fall beyond one standard deviation from the mean, all on the same side of the center line, it indicates that a potential trend or shift in the process is occurring. This data pattern suggests that the process may be moving away from the desired target. Could indicate factors like changes in the baking time, variation in the ingredients, or other influences that require investigation. It's like when you try to follow a recipe and somehow you end up with cookies that are constantly larger or smaller than intended. It's a clear sign that something in the process needs adjusting, just like our SPC chart reveals. All right, so let's keep an eye out for these trends as we dive into the next rule and uncover more insights into SPC chart analysis. Remember, when it comes to analyzing SPC charts, spotting trends and shifts is crucial. Whether it's cookie sizes or any other process that you're monitoring, these rules help us maintain control and ensure consistency. Imagine we're monitoring the cookie sizes once again and we notice a series of measurements. Now, suppose we observe 8 consecutive data points falling on the same side of the center line. This sustained pattern suggests a sustained shift or deviation in the process. It's like when you're baking cookies, no matter how carefully you follow the recipe, they constantly turn out smaller or larger than intended. 8 consecutive data points on the same side of the center line is a clear indication of a systematic change in the process output. You might be wondering what could cause such a persistent shift? Well, it could be due to a variety of factors like equipment malfunction, changes in ingredients, or adjustments in the baking conditions. So, just like a batch of cookies that consistently turn out different, it's time to investigate and make the necessary adjustments to bring the process back in line. As we dive deeper into the world of SPC analysis, remember the significance of observing sustained shifts. Identifying and addressing these deviations early can help maintain process consistency and product quality. Imagine we're monitoring the cookie sizes once again and we notice a series of measurements. Now, suppose we observe 8 consecutive data points falling on the same side of the center line. This sustained pattern suggests a sustained shift or deviation in the process. It's like when you're baking cookies, no matter how carefully you follow the recipe, they constantly turn out smaller or larger than intended. 8 consecutive data points on the same side of the center line is a clear indication of a systematic change in the process output. You might be wondering what could cause such a persistent shift? Well, it could be due to a variety of factors like equipment malfunction, changes in ingredients, or adjustments in the baking conditions. So, just like a batch of cookies that consistently turn out different, it's time to investigate and make the necessary adjustments to bring the process back in line. As we dive deeper into the world of SPC analysis, remember the significance of observing sustained shifts. Identifying and addressing these deviations early can help maintain process consistency and product quality. Now, let's uncover the insights behind the sixth and the final rule of analyzing an SPC chart: obvious cyclic behavior. Take a look at this SPC chart on my screen. The green area represents points within the acceptable range, while the yellow, orange, and red areas indicate points beyond desired limits, or at least points to give us pause. Now, imagine we're monitoring the cookie sizes once again. As we examine the data, we notice a distinct and noticeable repetitive pattern or cycle. This repetitive pattern is what we refer to as obvious cyclic behavior. It's like when you're baking cookies and you notice a regular sequence of larger and then smaller sizes repeating over time. When such an obvious cycle is observed in the process output, it suggests there may be underlying factors causing this repetitive pattern. It's essential to investigate and understand these cycles to ensure process stability and product consistency. For example, the cyclic behavior could be linked to variations in baking time, temperature, fluctuations, or even changes in ingredient quality used in the dough. So, just like a batch of cookies that exhibit a repetitive pattern, it's time to analyze the causes behind these cycles, and make any necessary adjustments to bring the process back in control. As we conclude our exploration of the six rules of SPC analysis, it's important to remember that we need to identify the causes of these trends. Recognizing and understanding these patterns can help ensure consistent cookie sizes and maintain process stability.